Welcome, everyone, once again. We're really happy to have you here for this past week. And this talk today is focusing on an important for us topic here at SciCat. And it has to do with education, training, and that young developers have to actually have in FATE issues. So I will just give you a brief introduction and related topics on fairness, perception, and explainability. And then I will give you an overview of a study that we did together with Maria Casinidou and Pinar Barlas at the Science Center of Excellence, with which I'm affiliated as well. And actually, Maria, when she was introducing me, she referred to it as RISE. RISE is a research center in Cyprus, and recently they have changed their name into Science, and the logo is on the screen here. So, algorithmic decision making is widely used for contributing to decisions that are affecting people's lives, like job hiring, healthcare, education, finance, and even criminal justice are just a few of the examples that we have seen algorithms to be taking over human decision-making ideas. And while the use of algorithmic decision-making has prospects to make decision-making more efficient and reliable, and as we have seen from Casey's presentation yesterday, this is the way the industry is looking into this. Concerns have been raised about the fairness and justice of those decisions. So these systems do not always behave as they should, making decisions that may discriminate against certain groups or people. And there are many examples that we have seen the past few days here at the Winter School as well. Zvika Kuflik, for example, discusses in detail several such examples. Jana Otterbacher provided you with examples that made the headlines. And yesterday, Joe and Frank from the University of Sheffield gave us some examples related to search engines. So we agreed here that fairness is itself complex, and there is a lot of work on fairness and justice constructs in the psychology literature. So a recent kind of research comprehensive psychology review can be found on the paper that I have here in the slides. With regards now to algorithmic fairness in decision making, we have recent work published in Human-Computer Interaction and the recently formed FACT community. They have looked into perceived fairness only to find that people understand fairness differently and according to the context where the system is operating. So, as users are becoming more aware of the concept of algorithmic fairness, they are starting to worry about potential biases in the decisions as well as in the data or the algorithm interaction. They want more information about how these different factors weighted in the decision and whether an algorithm uses sensitive attributes like gender and race, for example, to make the decisions. And we have seen in recent published work that variables such as the computer literacy, the favorable outcomes, for example, or the system development procedure have been proven to correlate with the perception of algorithmic fairness. So it is very difficult actually to predict what people would consider as fair. In particular, people rate algorithms as more fair when the decision is in their favor, irrespective of whether they know that they are biased towards certain other people or populations in general. So Pearson showed that there are gender differences in perceptions of algorithmic fairness as well, and different other demographic information attributes contribute to this variability of how we perceive fairness. Looking now at recent work on perceptions of fate. And if referring back again to Zvika's talk, we can find a great amount of work on how the users perceive elements of fate. However, we think that is equally, if not more important, to understand how the people behind the development of those models and algorithms perceive these concepts through the systems they are developing. But before going into that, let's talk a bit about explanations, which appear to be the most popular method towards transparency, with machine learning models being exploited for predictive sensitive individual information, classifying individuals into categories, and providing decisions that were previously taken by humans. There is a need for interpreting those models in a way that the user should be able to understand. So explanations is one such method, and there are different approaches that are providing explanations to different people. And here I will give you just some examples from the recent literature and how these are perceived by users. So if you take a look, these are studies that were published mainly in human-computer interaction areas. So what is important here is that the user should be able to understand the potential consequences of applying the decision in the real world, and hence explanations should be informative and easy to be understood and interpreted by the person they created for. So Edwards and Viale argue that pedagogical approaches to explanation, that is, explanations that teach how the model works, might be more suitable and promising for the general public compared to decompositional approaches that are breaking the model down to its components and trying to explain the technical aspects of it, with the risk of trading secrets and intellectual property breach, which might be more suitable for more technically knowledgeable people. And different categorization now for explanations is by Hancock and Lee, and there are three different types of explanations according to the audience. The local explanations that are focusing on explaining a particular output, the global explanations that are explaining how a set of outputs emerges from a particular input, and the counterfactual explanations that attempt to help the user understand how their input could change the output of the system by resembling everyday human conversation. And then we have a study by Vincent Cothor that they ran an experiment using different explanation styles. And what they found is that significant differences in justice perception between different explanations, particularly case-based explanations that presenting a case from the model's training data, which is most similar to the decision, have negatively affected justice perception, and compared to the sensitivity-based explanation, that is to explain how much of the value of a variable used in the model affects the output. There were other studies as well. For example, Rader and co-authors found that explanations in any form help to create awareness of how the system works and understand potential biases in the system, but they offer little in evaluating the correctness of the output. And also a different study on recommender systems, explanations in group recommendations have been proven to improve perception of fairness only if the majority group members' preferences or all members' preferences were taken into account. In other cases, they had no significant results. So studies with users are inconclusive as to what type or level of explanation they prefer. And here are some of the references that can be used if you are interested in this kind of research area. So finally, if we go back to the developers that I started with, Holstein and Kleanthous provide some important insights on how developers are struggling actually to find a balance between providing fairness in their systems and providing a product for their companies. And they are calling for procedures, processes, and training on concepts that are related to FATE topics. For the developers who are already in the business and they are actually developing those systems. So as I said at the beginning, it is important for us in SciCat to understand how future developers, young developers, or students in topics related to computer science and software development, how they deal with certain explanations provided in the scenarios they were provided in the study that I'm going to present in a few minutes, and look into how different decisions might change their perception. So have in mind that these people are people who are actually knowledgeable about how a system works and how AI works and how decision making works. So in order to do that, we ran a survey between September 19 and May 2020 with undergraduate and postgraduate students that are in disciplines adjacent to algorithmic development. Participants in this study, participation in this study was voluntary, and the participants provided us with written consent, informed consent for their data to be used for research purposes. And we recruited 19 participants, undergraduate and postgraduate students. You can see here that in their majority, the postgraduate students, and most of them were master's students. The rest were undergraduates, and they were in their fourth or third year of studies. You can see in the table, in the yellowish table, the degrees that they were pursuing. So computer science, information systems, data science, and so on. And it is also important to mention that most of them were studying at the European and UK universities. 7% were coming from the States, and the rest were coming from China, Brazil, Australia, and Israel. Okay, so what we did in this study, participants were presented with 3 scenarios. So here you see scenario 1 and 2, and later on we will discuss scenario 3. That in these scenarios, algorithms made decisions that influenced humans. We selected contexts that our target population were familiar with, and 2 of the 3 scenarios that you see here were actually aim to trigger the participants' judgment on the use of particular factors. As you can see here, we're using a number of different factors. Actually, scenario 1 was borrowed by a previous work that was published in CHI, if I'm not mistaken. And scenario 2 was developed by us. So in scenario 1, we can see it is a car insurance scenario where the user is trying to calculate a car insurance premium. So we give to the participants a description and the information of the user here, and also based on the information provided by the user, what the decision of the system was, and the explanation that the system provided to that user. In scenario 2 now, it's an airline rerouting scenario, and we are providing the participants with the parameters that were taken into account by the system for making a decision on 2 specific customers. Okay, so then we ask them to go through the scenarios, each scenario, and for each scenario to examine the overall perception of of their perception, basically, on these 6 constructs. The constructs were extracted from the literature and are related to fairness and justice. So if you go to the first reference that I gave you, the review on from psychology, you can see that each one of these somehow relates to justice and fairness. So this part was also extracted from the literature. And what we ask them to do is to go and state their agreement in a scale from 1 to 5 to all of these statements here. So agree with the decision, I understand the process, the factors that were considered, whether they are appropriate, the decision-making process, whether it's fair, and if the user deserved the outcome given the circumstances, and whether they will trust the system's decision over a human's decision. Okay, so now let's talk about the results. So I will just give you an overview of the results because this was a huge study, actually. I mean, a huge questionnaire, and we had several kind of results. So we had qualitative and quantitative results. So I will just give you an overview, and I will direct you to the paper at the end. So we were expecting that the people who indicated agreement with the system's decision in the scenarios provided before would also believe that the person in the scenario deserved the outcome, since they agree with this decision. But surprisingly, we found significant statistical differences in their opinions in both scenarios, scenario 1 and 2. There was a considerable number of participants who, although they agreed with the decision, they said that the person did not deserve the decision, the outcome of the decision. So when we asked them to actually elaborate more, in scenario 1, participants focused on important factors about the situation that were not taken into consideration. And this included the context of the day of the accident, the time, the road infrastructures, for example, and so on. And interestingly, some participants even mentioned the need to consider other factors apart from those that were provided in the scenario. They indicated that even when they selected in the scale the sufficiency of information. So although they said that the information were sufficient, they indicated that they needed more factors should be considered in these scenarios. They referred to similar cases on which the prompt said the decision was based, although the prompt explicitly stated twice that the decision was based on thousands of similar cases from the past. Participants often remarked that a single example is not enough to adequately explain the decision. And they also mentioned the decision-making process. Most participants wanted to know how much each factor contributed to the decision. And some specifically were asking for additional explanations on how age, the driving at night, for example, affects the probability of having an accident, and so on. Now, if we go to scenario 2, the participants said that the process of the decision-making was, they thought that this wasn't right, it wasn't the proper one, and the vast majority of the responses asked about and offered other important factors that the system should consider in this context, such, for example, the health condition of the person in the flight, the reason for their flight, and the disability status, and so on. And specifically, some participants argued that the factors mentioned in the prompt were irrelevant to the scenario, and they were referring to the age and gender in their responses. Okay, so we were also interested to see whether people who found the factors used in the decision-making process appropriate will also think that the decision-making process is fair. And our results showed significant differences between the responses of the participants in scenario 1 and in their majority reporting that the factors used in the decision-making process were appropriate. However, they do not believe that the decision-making process was fair. And in scenario 2, we found that the majority agree that the factors used in the decision-making process were not appropriate, and thus the decision-making process was not fair. So the qualitative results for scenario 2 prompted to gender and age as factors to be determined. So this was actually a good result for us, because we saw that people that are knowledgeable, I mean, they understand how these factors can affect the output of the system, can actually pick this information. Now, we also were expecting that people who indicated the decision-making process was not fair, that they would not trust the system's decision more than a human's decision. And here, the majority of the participants in both scenarios believe the decision-making process was not fair, and they indicated that they would not trust the system's decision more than a human's decision. So this was the same result for both scenario 1 and 2. Okay, so now moving into scenario 3, which is a completely different approach. So here we have two candidates, person A and person B, and they were identical in every way except their race and the loan repayment rates. What they wanted is to apply for a 50,000 loan to start a business, and the loan officer only had 50,000, so there has to be a way to satisfy both ideally. So the system that was making this decision had three outputs, different outputs that were given to the participants, and for each output, they had to again answer the same questions to state their agreement with the 6 statements that I mentioned earlier. So yeah, we had significant differences on their responses with respect to agreement, appropriateness, fairness, whether they deserved the outcome, and trust. When we try to see whether there are differences between the cases, the different cases. And specifically, when we check with a postcode test, we see that participants perceive decisions in case B, the proportional outcome, as the most just compared to the other two, and the case C, which was the for person A to take all the money, as the least just, as the least fair. And looking into the qualitative responses of the participants, so for each scenario and each case, we wanted to get their responses on, I mean, to understand their way of thinking, or their the reasoning behind their responses. So we had to analyze a huge number of qualitative responses in this one. So in case A, the majority of the participants were asking about specific information missing. So they wanted more information about the decision, why the decision was in this way, how it was calculated, and so on. And they were yeah, and this is the reason basically that they thought that this is not an appropriate decision. The process was the second most common theme regarding case A, and also for case C. So they thought that this was not also a good decision. And race and gender was actually referred to all of the 3 cases, irrespective of the output. So although they agreed that the case B was more appropriate, they wanted more information, and they thought that race was not a good factor to be taken into account. So since this study ran with undergraduate and postgraduate students in the fields adjacent to algorithmic development, it was natural for us to examine whether the participants' level of education made a difference in their responses. So in scenario 1 was the only scenario that we found statistical significant differences in the understanding of the process between undergraduates and postgraduates, with postgraduate students indicating that they understood the process that the system is following in making a decision better compared to undergraduates. In the other 2 scenarios, we didn't have any significant differences regarding these, and also we didn't get any other significant differences in the other constructs for scenario 1. In scenario 3 now, in case B, where is the proportional case, undergraduates find the information provided less sufficient compared to postgraduates, and looking if there is a difference in the agreement in the decision. For case C, undergraduates agreed less with the decision of the system compared to the postgraduates. And following the similar line of thought, we examine whether there is a difference in the perception of appropriateness of the factors used in the system. In case C, undergraduates considered the factors used in the system for making the decision less appropriate. Finally, undergrads indicated that the decision-making process was less fair compared to the postgraduates. Okay, so in this survey, apart from the scenarios, so these were the results that we got from the scenarios, a sample of the results. In this survey, we also wanted to see how young developers define algorithmic fairness in their own words, and to see, given a scenario, hypothetical recruitment system that they were called to develop, how they would make the system more transparent, who would be held accountable if their system behaves unfairly, and what could be possible causes of unfairness in that system. So, finally, we also ask them regarding their training and knowledge on FATE topics in the end, just because the literature mentioned that training and education made a difference in how we perceive these the fairness constructs. So the replies in the previous these questions were in free text. So we had to thematically analyze the responses of the participants. And here you can see a sample from participant 68. So algorithmic fairness, as far as we understood from their responses, is subjective for each individual who took part in this study, and defined fairness according to their own understanding, their background, and their knowledge. And this is, of course, very, it was expected. The participants defined fairness through these categories that you can see here. So the largest theme in the responses here is the objective factors. Many students felt that algorithmic fairness has to do with the factors within the model, and that is often defined in opposition to discrimination and bias based on demographics, especially, which can be seen in the use of outputs by algorithmic systems. Now, the scenario we've given to the participants for the remaining questions is this one. So you work as part of a team which is developing a system to filter and rank CVs. And based on these attributes here, the system will make a decision about the applicants and rank them accordingly. Okay, so we ask them what can be possible causes of unfairness in this system. Of course, the majority, they refer to the use of sensitive attributes by the system to make a decision. The possibility of the system to be unfair due to the weights that were used within the model and the training data set that will be used to train the algorithm. Of course, they also mention the human aspect, so how the human who will be defining the model can influence the output of this system. Now, under transparency strategies, as was expected, most of them were referring to explainability approaches. So this was the most popular theme that we've came across. So explanation of the algorithm, explanation of the output. Others refer to auditing processes as a method for providing transparency. Others were writing, for example, that maybe it's best if we give an example from the training data set and so on. So, but it's important here to see that the majority, I mean 53 out of the 99 responses, they were talking about explanation of the algorithm. Now, the majority of the participants agreed that with the statement that their team should be held accountable in case that the system behaves unfairly to some parts of the population. And for us, this is promising, as it may be an indication that the future generation of developers understand the responsibility of delivering fair behaving algorithms to their users and the possible consequences that these might, I mean, their systems might have in the society if they behave unfairly. And this is also what a previous study found out with practitioners, actual developers, that they are working in developing those systems, that they are indeed very cautious about the fairness of their systems. And the need to incorporating seminars, modules, and training courses in the computing related degrees, as well as professional training courses for practitioners, was evident in our study as well. The majority of the participants, although students in degrees close to computer science and algorithmic development, they did not have any training and do not believe they are knowledgeable in FATE topics. So this was again a very important outcome for us. Similar to previous work, now we found that factors are context and output dependent, especially based on our qualitative analysis as well. Something that is also obvious from the quantitative results we got, and as I said before, the qualitative results. Surprisingly, in the scenarios describing the car insurance and the airline rerouting, participants tended to both agree with the decision, but believing at the same time that the person in the scenario did not deserve the outcome, which is something that we need to explore further. Considering that participants often noted that some important factors were missing, this could imply that the participants find that while the calculations were accurate by the system, the process needs to take into account other factors and therefore does not actually calculate the most just decision for the person in the scenarios. Participants generally find that some important factors were not considered, highlighting the complexity of real-life situations and the context-dependent nature of these systems. Now, if we want to wrap it up and bring it all together, I mean, from also what we've heard from previous talks here at the Winter School, fairness and justice when it comes to algorithmic systems are not very straightforward. They're very difficult to be defined, and they're very difficult to be reflected within the algorithmic systems that we are developing and we are using every day. We need several parameters to be taken into account, and factors are context and output dependent. And of course, it's very difficult to reflect this into the complex systems of the complex nature of intelligent systems. Explanations, although they are the most popular approach that both the general public and the developers are looking into, might not always be the solution to fairness and transparency, as we have seen from this study and also the review that we did through the literature earlier this year. And of course, different explanation styles should be considered according to the audience. And this brings us back to Professor Fausto Giuchilia's talk earlier this week, that we are all individuals with our own viewpoint. We have diverse cultural background and, of course, knowledge, and this should be taken into account when we are auditing, when we are assessing, when we are developing these complex systems. So, as I said earlier, this is just an overview of the results that we have. And to find out more, next month we're presenting our paper at FACT conference with the title, "I agree with the decision, but they did not deserve this, future developers' perception of fairness in algorithmic decision." And just some advertisement here. We have a workshop that is taking place in conjunction with ACM Intelligent User Interfaces in collaboration with Casey from IBM, Zvika Kuflik from the University of Haifa, and other academics and researchers from the States and the UK. So if you're interested, join us. We have more than 20 papers submitted to the workshop. So it will be very interesting to collaborate and discuss with like-minded people.